All right, so we reviewed Chapter 2, Lesson 1 and 2, and then I said, hey, tomorrow you need to have this book. So if you don't have it in here right now, you didn't follow directions that's on the board when you came in from recess, please pause the video now and give me a free chance to go to your locker for free without any consequences. Get your book and come in. Those would be the follow directions. You listened to the last video or you looked at the board. Thank you for being prepared for class. All right, so we reviewed how to create common denominators in order to compare them as one of our review lessons in the previous lesson. So that's going to be key and vital to this lesson right here. You're getting a piece of paper that has 4 different sets of questions because we always ask, dealing with fractions, can I do this math? Because on 3 of those occasions, yes, those functions of math, adding, subtracting, and multiplying, I can do it. Division, the answer is no, so I got to figure out what to do. But by asking the questions, we build this routine in our mind, and we can constantly go back to that routine, and it'll help us with our math now, for homework, this year, next year, and in the future. So some of you may be remembering about adding fractions and subtracting fractions. And some of you may just be simply asking, can I even do that? We learned it in 5th grade because it was a 5th grade standard, but we're reviewing it today because we're going to be using it from this point forward throughout the year. And the first answer to that is yes, indeed. I can add and subtract fractions, but I have to have something that's very important in order to successfully do them. What do I have to have? Well, I have to have a common denominator. So that ought to be terms that sound familiar that we did in comparing our fractions. Getting a common denominator is key. Now, if I have it, if they're being nice to you, and you say, yes, I have a common denominator, then you keep that denominator. This is important. There's a lot of people get confused and they add everything. I can't. I have to keep my denominator. Then I do the math with the numerators and only the numerators. If it's adding, I add the 2 numerators. If it's subtracting, I subtract the 2 numerators. Then I always see if I can reduce my fraction as my answer. But if the answer is no, I don't have a common denominator, then I got to do some math. Now, they teach you this term of least common denominator. I don't really care for it, but I am going to show it to you because as we have said multiple times all year already, and we've only been for a month, you're going to hear me say it all year. There is more than one way to do a math problem. It's not wrong math. It's just, to me, not the easiest math. A second way that we could do that is if I have a larger denominator and a smaller one, and they're being nice to me, I ask, well, can that small denominator go into that larger one evenly? And if that's yes, I know I'm going to keep that larger one and just change the smallest one. It's a little bit easier. The way that I find that's easiest, if it's not a large and small one that works together, is just by multiplying by opposite denominators. So when we get started, we're talking about some terms here that maybe we're not used to. Unlike fractions. So if they're not identical, like 1/5 and 3/5, they're not identical fractions, but they are like fractions. So the difference between like and unlike fractions only has to do with the denominator. If I have 1/5 and 3/5, they have the same denominator, so they are like fractions. But if they're not alike, if I'm talking about 1/5 and 2/3, not the same denominator at all. Those are unlike fractions. And those are the things that I have to change in order to do adding and subtracting. This least common denominator, we're going to show you on this first one. Once again, it's not wrong math. I just don't think it's the easiest math for everyone to understand. So as we get into this, I'm going to say it all year. And it's important. And I'm seeing some of you fast forwarding the videos, waiting until you see an answer and you're thinking about what you had for lunch or what happened at recess or what you're doing today after school. And then you pause when you see something worked out and you just copy it down. You're not learning. Okay, so as we said from the first day of school, we have to listen. Engage our ears work fine. Engage our brain, thinking about, and having our hands doing what we need to be doing. Taking those notes. We're building what's called muscle memory. And when my muscles are doing it, it engages my brain. I'm thinking about what I'm doing. I'm following along. I'm learning this process. And then I have a whole bunch of problems worked out that Mr. B did with me that I can open up in this Hidden Success book tonight, and I can look at it and say, oh yeah, I remember what we did today, and then I'm successful with my homework. So on this first question, they introduce us to a roadrunner. They tell us about the body. They tell us about the tail. We have 5/6 of a foot and 5/9 of a foot. Okay? They just want us to add them together. All right? So when I look at the problem, the first thing it says to do is estimate. And I want to tell you right now, we're not estimating on this assignment. So anywhere it says estimate, cross it out. On your homework, it says estimate. Cross it out. We're not estimating. We will estimate later on. No reason to double our work. Then I go through my questions. All right, so can I add fractions? Yep, I sure can. What do I have to have? I have to have a common denominator. So I look at it. Do I have it? Nope, I have unlike fractions, don't I? I have a 6 and I have a 9. So here's that least common denominator idea that they are introducing you to. They say, okay, let's show our least common multiple of 6 and 9. Well, they don't really use the least common multiple. So that's one of the problems I have with this example. If they use the least common multiple, then it would make more sense to me. They just randomly chose a multiple. The thing is if it's not truly a multiple of the two, and once again, multiples means to multiply, then it's not going to be the right answer. But when I list the multiples, notice in my first 6, I actually have 2 that compare. 18 would be my least common multiple, but they say, well, let's just use 36. Okay, more than one right way to do a math problem, right? Let's do it. So they're showing us some information here. They already have several pieces of it filled out. We're going to talk through it so we know what they're saying. So if we're saying I'm going to use 36 as my common denominator, because it is a multiple of both of them, then I'm making sure that that's going to be what I'm focusing on each of my fractions. So they say that I have 5/6. But what am I doing to my denominator? Because that's all we're focused on right now. To get to my 36. Well, they're saying I'm multiplying by 6. And as we've said for a couple lessons now, whatever I do to my denominator, I have to do to my numerator. So they're multiplying by a form of 1, 6, 6. Once again, that does not change the value of my fraction because 6 over 6 is a form of 1. But it does change the digits that make up my fractions to where I can use them in my math problem. So let's look at the 5/9. It isn't filled in, so you should be filling it in with me. We know we're getting to 36 as my denominator, but then I have to ask, well, what am I doing to 9 to get 36? And if that questioning doesn't quite make sense to you, here's something else to ask. Well, if I divide 36 by 9, what do I get? 36 divided by 9 equals 4, right? So what am I doing to 9? I'm multiplying it by 4. So therefore, I have to multiply the numerator by 4. And 5 times 4, that gives me 20. So that's my new numerator. Now I have like fractions, right? I have like terms in my denominator. I have 36 plus 36. What do I do with my common denominator? Well, if the answer is yes, then I keep my denominator and I do the math. So now it's 36. 30 plus 20 is 50. Now, on this, you can either reduce first, and then, because I'm top heavy, I can divide, or I can divide first and then reduce. Doesn't matter which order, I'm going to follow the order that the book is set up for you. They say, well, they're both even numbers, so I'm going to reduce. And reducing, once again, dividing numerator and denominator by the same number, sound math. So I'm always going to reduce any fraction that I'm given. So I'm going to reduce by 2's. 2 goes into 50 25 times, and 2 goes into 18 or 36 18 times. All right, we're good with that. That gives me 25 18ths. Now that's top heavy. That means the largest number is larger than the bottom number. That's called an improper fraction. I cannot have improper fractions in my answer. Now, the secret is, later on, we're going to get into ratios and rates and unit rates. We're going to be getting into some math later on where it's not really looked at as an improper fraction, and I'm going to keep it that way. Okay? We'll come back to that. So in my math, when I'm multiplying or adding and subtracting my fractions, when I'm multiplying my fractions, when I'm dividing fractions, I can't have an improper fraction as my answer. So I have to go to the math that it is. And what type of math is it? Hopefully division popped into your head. My numerator goes inside, so that's my dividend. My denominator goes on the outside, so that's my divisor. And I'm going to divide remembering that when I'm doing this, I'm creating a mixed number. I'm creating a mixed number or a fraction. So I have 18 going to 25 one time. Then I'm just going to make whatever my remainder and my divisor are as my fraction. So I know 1 times 18 is 18, and I subtract and I get 7. My remainder is my numerator. My divisor is my denominator. So I'm going to have 7 in the top, 18 in the bottom. So my answer is 1 and 7/18. If I add the fraction of a foot that the body of the Roadrunner is, and the fraction of the foot that the tail of the Roadrunner is, how big is it? It is 1 and 7/18 of a foot. All right. I'm going to show you the way that I think is easier. Now, you don't have to copy this down, but I would like you to follow along and listen. If you want to, then please, by all means, please get an extra piece of paper and follow along and fill it out. I'm going to talk a little bit faster because I don't want this to be an extremely long video, but I want you to see that I think there's an easier way other than just finding a least common denominator. If I look at it, then I'm going to just say, hey, I do not have common denominators, right? I have unlike terms, so this is a no down here, so I know I have to change it. So I'm going to multiply by opposite denominators, which is what we did when comparing fractions, right? So if this is a 6, I know I'm going to multiply that fraction by 6/6, the same form of 1. And over here, my denominator is a 9, so I'm going to multiply by 9/9, still a form of 1. Then when I multiply those out, then I'm going to have 5 times 9 is 45, and 6 times 9 is 54. My denominator is 54, so I should get the same thing in my denominator on the other side, since I multiply by opposite denominators. 9 times 6 is indeed 54, so I know I'm good to go, and 5 times 6 is 30. So now I have those two fractions. They look completely different than what I had before, but that's okay. So once I have a common denominator, what do? I keep my denominator. So my 54 stays the same, and then I add my numerators. 45 plus 30 is 75. Now I know that I can reduce both of those by 3. How do I know that? Thinking back to Chapter 1, Lesson 1, 1A actually, we had our divisibility rules, and we had our prime lesson. Our divisibility rules of 3 was if I add the digits together that make up a number, and 12 will go into their sum, or excuse me, 3 will go into their sum, then I know 3 is divisible into that number. And 7 plus 5, this is where I got my 12, is 12. 3 goes into 12 evenly, so I know 3 is a factor. 5 plus 4 is 9, 3 goes into 9 evenly, so 3 is a factor. So I'm going to reduce both of those by 3 and look at what we get. When I reduce by 3, 3 goes into 75 25 times. Should make sense, 3/4 is 75 cents. 3 goes into 54 18 times. Takes us right back to what we had when we reduced their 36 denominator. Showing that once again, math can be done in multiple ways. Which way you do best and you're successful with, that's what matters to me. When I divide 25 by 18, I still get the 1 and 7/18, so I know that my answer is still correct. All right. Now they give us example 1, and it's subtracting. Well, subtracting is done the exact same way as adding, other than when I do the math, I make sure I subtract. Have the same questions, and I always start with my questions. Can I subtract? I absolutely can subtract. I have 7/12 minus 1/3. So I know that here's an important thing. It's really good to stack them when you're adding, but it's not really necessary. But if you want to be successful, always stack adding and subtracting the fractions. It makes it much easier to line everything up and see what you're doing. I would strongly advise it to make you a better math student. I always stack my subtraction and fractions. I always stack my adding also. So if I have 7/12 and 1/3, I start asking my questions. I know I can subtract. Do I have a common denominator? No, I don't. They're unlike terms, right? Unlike denominators. So if no, I have to get one. So here was that second way I told you it would work. I look at my two denominators and I find my biggest one, and my biggest one is 12. And I look at my smallest one, I said, well, will that one go into it evenly? Does 3 go into 12 evenly? Hey, it sure does, doesn't it? So I'm going to keep that 12, and that's going to become my common denominator. Now, that circle should be around the 12, so I apologize, it didn't line up quite right. So then I have to ask, well, if that's the case, if I'm keeping the 12 as my common denominator, I need 12 over here. What am I doing to the 3 to get 12? Well, I'm just multiplying by 4, right? So if I multiply the denominator by 4, I have to multiply the numerator by 4. Have to do the same in top and bottom. And 1 times 4 is 4. Now, what I have is 7 twelfths minus 4 twelfths. Do I have the same denominator? I do. What do I do with that denominator? I keep it. I always keep it. 12's going to go down at the bottom. Then I do the math with the numerators and only the numerators. 7 minus 4 is 3. If I get a fraction as an answer, then I always see, can that fraction be reduced? And it can, because 1 plus 2 is 3, and 3 goes into it. 3 goes into itself. So I know I'm going to reduce by 3's. 3 goes into 3 one time. 3 goes into 12 4 times. So my final answer is just simply 1/4. All right, continuing on in our practice then. The next example they give us is, holy cow, what is that? It's a letter. I can't add an H to it. So welcome to algebra. Algebra is where I'm going to use numbers and things called variables, which are letters, and solving for math. The nice thing about right now in our algebra is they're telling you what the letter is equal to, and you just have to plug it in and do the math. They tell me that I'm going to add or evaluate 2/3 plus H, and that H stands for 2/5. All right, so that should be pretty easy. I have 2/5 plus, or 2/3 plus 2/5. Notice on this one, they stacked it for you. Makes it easier, I truly believe that. All right, so will 3 go into 5 evenly? No, it won't. That doesn't help us at all. So they say if you find the least common denominator, well, I'm going to skip that. Let's just multiply by opposite denominators. Okay? So if I look at what I'm dealing with, I have to rename my fractions in order to do the math, because I can't go to this point until I have a common denominator. So I have a 3 up here. So down below, my opposite denominator, I'm going to multiply by the 3. So I have a 3 and a 3. Down below, I have a 5. So up here, I'm going to multiply by 5s. Notice what happens to my denominators. When I multiply, I have 3 times 5, which is 15. 5 times 3, which is 15. Common denominator. My numerators, 2 times 5 is 10. 2 times 3 is 6. Then, what do I do with the common denominator? And this is key, because some people will just rush through it and they'll end up with 30 as their denominator. Wrong answer. Have to keep my denominator. Okay? So when I have my denominator 15, then I can add my numerators. And that gives me 10 plus 6, which is 16. Top heavy, right? Can't have it. It's an improper fraction. So I'm going to have to divide. And when I divide, I have 16 divided by 15, which is 1 whole and 1 left over. So remember how to build that fraction? My remainder is my numerator. My divisor is my denominator. And I end up with 1 and 1/15. So 16/15 is actually 1 and 1/15, which is the answer that we need to keep. All right, so here's our practice problems. Kind of what we're going to see on our homework, right? Once again, we're not going to estimate. Once again, you need to follow along with me and make sure you're showing step by step and you understand it. Yeah? So when we start out, once again, we have our questions. This is adding the fractions. Can I add my fractions? Yes, I can. Do I have the same denominator? Nope, I don't. So I have to change my denominator, then keep it, and then do my math. So when I look at it, will my smallest denominator go into my largest one evenly? They will, won't they? 3 will go into 12. Okay? But I could also, showing you there's once again more than one way to do the math, just multiply by my opposite denominators. So I have 2/3 plus 1/12. My opposite denominators then are 3's, right? So if I multiply by 3's, then I have 12 times 3 is 36. So I'd have 3 over 36. And then over here's a 12. 12 times 3 is 36. That's going to be my common denominator. So when I have 36 as my denominators, I have my 12 times my 2, which is 24, and 1 times my 3, which is 3. I keep my denominator of 36, and then I add my numerators. 24 plus 3 is 27. Can that be reduced? Well, they're not even, right? So 2 doesn't work. What about 3's? 2 plus 7 is 9. 3 works. 3 plus 6 is 9. 3 works. I know I can reduce by 3. So if I reduce by 3, once again, dividing by the same number. Well, then I'm going to get into a situation where I can reduce again. So on the previous lesson, I showed you how you can divide in multiple steps. But some people like to just divide by the largest number they can when they reduce. Well, 9 will go into both of them. So if I know my, shouldn't have had that up there. If I know my rules of 9, well, 9 times 3 is 27, and 9 times 4 is 36. So I could reduce by 9 instead of reducing by 3 and then reducing by 3 again. So if I reduce by 9, I can do it all in one step. 9 goes into 27 3 times, and 9 goes into 36 4 times. So my final answer on practice 1 is 3/4. If I want to reduce by 3's and reduce by 3's again, then I would see that when I reduce, 3 goes into 27 9 times, which is correct, and 3 goes into 36 12 times. But then that 9/12 has to be reduced by 3's again, which will still give you your 3/4. More than one way to do a math problem. Both ways are correct. All right, so on number 2, subtraction. Can I subtract fractions? Yes. Do I have the same denominator? Yes. They're nice to you on this one. So all I only know is if it's yes, I just have to keep it and then do the math with my numerator. So I know my denominator is 18, and then 11 minus 3 is 8, right? 8, 9, 10, 11? Yeah. They're both even, aren't they? So I know I have to reduce. So when I reduce, and I reduce by 2's, because they're both even, then 2 goes into 8 4 times, and 2 goes into 18 9 times. Can 4 9's be reduced? Nope. So 4 9's is my answer. All right, so what about 4 15ths and 2 5ths? Well, I can add. Do I have the same denominator? Once again, nope, I don't have the same denominator. So I'm just going to multiply by my opposite denominators. Over here I have a 15, so I'm going to multiply top and bottom by 15. And then over here I have a 5, I'm going to multiply top and bottom by 5. Then I rename my fractions. Once again, doesn't change their value. It just changes the digits that make up the numerator and denominator. So when I notice I have 5 times 15 and 15 times 5, then I have a common denominator of 75, and that's the goal, because we have to get it in order to do the math. Then I find my numerators. 5 times 4 is 20, and 2 times 15, well, that's 30. So then I can do my math. What do I do with my denominator? I keep it, right? So my 75 has to stay, and then I add my numerators. 20 plus 30 is 50, and then I'm going to reduce. Now, you can reduce by 5's, but you're going to have to do it again. So if you think about money and quarters, well, I know 2 quarters makes 50 cents. 3 quarters makes 75 cents. I can reduce by 25 on this problem. If you want to reduce by 5, please do. It's okay. You're going to get 10 over 15. But then you have to reduce by 5 again. So if I reduce by 25, I get to do it just one time. So 25 goes into 50 twice, and 25 goes into 75 3 times. All right, so let's skip to 5 and 6. So this is where we're doing our introductory to algebra. We have an addition and a subtraction. They tell me what y is equal to and what n is equal to. So I just have to write my problem that way to begin. So I have y is equal to 3/4 on this one. The n is equal to 1/6 over there. And I have 7/16 plus, then I plug in the 3/4. I don't have my common denominator, do I? So I need to find my common denominator. I'm just going to multiply by my opposite denominators. So here's a 16. I multiply by 16 in top and bottom. Here's a 4. I'm going to multiply by 4 in my top and bottom. When I multiply then, I find my common denominator is 64. Because 4 times 16 is 64, and 16 times 4 is 64. Now I do my numerators. So 7 times 4 is 28. And 3 times 16 is 48. Now I have my common denominators. What do I do with it? I keep the denominator, right? So if I keep my denominator 64 and I do my math in the numerator, then 28 plus 48 is 76. Now I'm improper. So instead of reducing first, which I could because they're even, I'm going to show you that I can divide first and then reduce when I'm at the end. So I'm going to take my 76 and divide it by 64. That goes in one even time, because 1 times 64 is 64, and then when I subtract them, I get a remainder of 12. Once again, my remainder is my numerator, and my divisor is my denominator. So I have one whole, a numerator of 12, and a denominator of 64. But they are even, and I know I can reduce. I could reduce by 2, and that would give me 6 30-seconds. Then I have to reduce by 2 again. 4 can let me do it in one step. I don't care which way you do it, as long as you get it correct. So either way, more than one way to do a math problem. So if I do it, then I keep my 1 as my whole. 4 goes into 12 3 times, and 4 goes into 64 16 times, and that's as low as I can go. All right, so now I do subtraction. I set it up the exact same way. They tell me what n is, so I have 2/3 minus 1/6, and here's the important thing. Don't switch them. My first one is listed as 2/3 minus n. You have to keep it in that order, because then you're going to end up with negative numbers. We're not ready for negative numbers until much later on. I do not have common denominators, even though I can subtract, so I have to find it. So I, once again, believe that multiplying by opposite denominators is the quickest and easiest way. So here's a 3. I'm going to multiply top and bottom by 3. Here's a 6. I'm going to multiply by top and bottom by 6. Once I've done that, then I see that my common denominator is 18 between the two of them, because 6 times 3 and 3 times 6 is 18. So now my numerators is 6 times 2, which is 12, and 1 times 3, which is 3. What do I do with my denominator? I keep my denominator, and then I do the math in my numerator. And 12 minus 3 is 9. Hopefully you see really quick that you can reduce that. If you don't, you know that 3 will go into 9, and 1 plus 8 is 9, and 3 will go into it. So you could reduce by 3. Okay? If you do that, you're going to get 3/6. Then you have to reduce by 3 again. Instead, I'm going to reduce by 9s, because I know that 9 goes into 9 one time, and 9 goes into 18 twice. So my final answer just simply becomes 1/2. All right, so then we're going to jump to 13. Find the sum or difference and write less than, greater than, or equal to. All right, so we got to just do the math is what they're saying and then compare them. So I'd have to have common denominators once I compare them. But in order to do the math, I also have to have common denominators. Got some work to do. I have 3 and 4, which is not a common denominator. So I know that when I set them up, keeping them in the same order, I'm just going to multiply by opposite denominators. Here's a 3, I'm going to multiply by 3's. Here's a 4, I'm going to multiply by 4's. My common denominator becomes 12. And then I do my numerators. 4 times 2 is 8, and 1 times 3 is 3. When I subtract those then, I keep my denominator in my answer, and 5 minus 3 is, or 8 minus 3 is 5. So I know I have 5/12 on this side. Now let's do the other side. So I have 6/10 plus 4/15 multiplied by opposite denominators. I have a 10, I'm going to multiply by 10 and 10. I have a 15, I'm going to multiply by 15 and 15. Calculators, once again, are really friendly in this type of situation. I know I'm going to get a denominator of 150. Okay, well, if I multiply my numerators then, 15 times 6 is 90, and 4 times 10 is 40. I keep my denominator on that addition problem, and I add my numerator, so 90 plus 40 is 130. So now I'm comparing 5/12 and 130 over 150. All right. Now when I reduce that, before I compare them, all I have to do is cross off those zeros, right? Remember that shortcut? If they end with a 0 on top and bottom, get rid of it. Same way with dividing. If I'm dividing by something that ends with a 0, and my dividend on the inside ends with a 0, Get rid of those zeros. Easier math. So what I'm actually going to compare is 13/15, which will make my math a lot easier. Now I'm still going to multiply by opposite denominators. So I have a 15 over here. I'm going to multiply by 15s. I have a 12 over here. I'm going to multiply by 12s. When I multiply through, I get my denominators that are common, which is 180. Then I can multiply my numerators. 5 times 15 is 75, and 13 times 12 is 156. Now I'm ready for my final step. Do I have the same denominators? I do, 180. Which one is smaller in my numerators? Well, 75 is smaller than 156, right? So my arrow is going to point to the left. All right, so go back to 4. Now this is important because I want to make sure you get this, and this is the only way you can prove to yourself you honestly get this. You don't have questions. I want you to ask the questions as you're working through, and then I want you to solve. Okay? So this is your time to do it on your own. So once you find your answer, then unpause the video. But right now, pause and work through it. All right, so hopefully you worked through it and you do have an answer. Now let's see how we did. You saw that you have unlike terms, right? You don't have that common denominator. So the easiest way, not the perfect way, it doesn't have to be your way, but as long as you end up with a common denominator, then you're still going to be good to go. I multiplied by 6s, I multiplied by 12s, and I get a denominator of 72. And then in my numerators, I had 60, and I have 30. Keeping your denominator and subtracting, you end up with 30 over 72. And then you would have to divide in order to reduce. So dividing 30 by 6 and 72 by 6. If you divide it by 2 and then divide by 3, still the same process. Or maybe you divide it by 3 and then divide it by 2. Still the same process. 3 different ways I could reduce this one. But you should have ended up with an answer of 5/12. So as we're going through these, I got a couple more. I want you to work on your own. Don't try to cheat me. Don't try to cheat yourself. Work on your own and find the answers. Pause the video now and then come back and I'll work through it. So hopefully you have an answer where you took 3/8 and you put it in front and you added it to 1/2. Okay? You found a common denominator. Maybe you saw that 2 went into 8 and you did it that way and kept your denominator of 8. I'm just multiplying by opposite denominators because it's the quickest way in my opinion. So I multiplied by 8s and multiplied by 2s. So my new fractions I end up with is denominators of 16, by multiplying by opposites. 2 times 3 is 6, and 1 times 8 is 8. Keeping my denominator, I end up with 16 as my denominator. My numerators, 6 plus 8 is 14. And then I have to reduce. When I reduce, I'm reducing by 2s because they're both even, and that's as low as I'm going to be able to go. So hopefully you got an answer of 7/8. If you did, fantastic. If you didn't, figure out why. And if you did it a different way than me, there's a person in your classroom that's an adult that has a minor in mathematics that can help you figure out where you messed up. All right, I'd like you to do the same thing on number 14 then. Okay? Solve both sides, come up with your answers, decide how they need to be compared, and then come back and check your work. Pause your video now. All right, so hopefully you have an answer there. It's either going to be pointing to the left, pointing to the right, or it's going to be an equal sign, but we need to figure out how. So hopefully you figured out you need a common denominator on the left, multiplying by opposite denominators. I find this easier. Here's a 2, I multiplied by 2. Here's a 3, I multiplied by 3s. My new denominator became 6s. 3 times 1 is 3, and 2 times 1 is 2. And when I add those together, I got 5/6. On the other side, though, I notice I have common denominators. They were really nice to me. I just kept it. My denominator stayed at 5, and then I subtracted. 4 minus 2 is 2. But my denominators are still not like terms, right? They're unlike fractions. So now, between 5/6 and 2/5, I need a common denominator. Once again, multiply by your opposite denominators. So I have a 5, I multiply by 5s. I have a 6, I multiply by 6. Should get a common denominator of 30. And then my numerators, 5 times 5 is 25. 2 times 6 is 12. Which one's bigger? Which one's smaller? Remember, the arrow always points to the smallest. So when I look, that should be a 25. the arrow should point to the right. Ignore that 5. Because 12 is smaller than 25. Alright, so these are going to be extra in case you're really confused and you're not really sure what we're doing. This video is a little shorter than the ones we've had previously this week. But if you have questions, please come back and ask, and I'm willing to help you. Okay, if you missed something, you didn't quite get, rewatch the video. Okay, if you really weren't paying attention, rewatch the video and pay attention and participate. Here's your assignment, and once again, it's in your In Success book. That's why the page number suddenly dropped. We're doing pages 11 and 12. We're going to do questions 2 through 14, and we're going to do questions 1 through 6. Be sure to ask your questions. That's why I'm giving them to you on a piece of paper. Put it in your math folder and keep it with you, because you'll need those throughout the rest of the year. When you take your test, you can get those questions out, and it'll help you go through the process. If you have any questions, then please come and ask.